In this video, we will see projects related to soil sensor, smoke sensor, PIR sensor and color sensor. Please watch the full video. Thank you.
Today I am going to introduce you to the one of the most famous sensors from Arduino community, that is smoke sensor. The MQ2 is a gas and smoke sensor that can detect a wide range of gases including LPG, propane, methane, alcohol, hydrogen and of course smoke. First, you need an Arduino Uno, the brain of your project, and of course, some jumper wires and USB cable to connect the Arduino to your computer. Then, you need the MQ2 gas sensor module. Make sure you get the module version, not just the bare sensor, because it already has the comparator circuit built in. Then, a breadboard for prototyping. Next up, a buzzer. This is going to be an alarm and an LED with 20 ohm resistor to give us a visual alert. Okay, now let's take a look at the implementation. I already got everything wired up here. So let me walk you through the connections first and then we'll look at the code. First, the wiring. The VCC pin of the MQ2 goes to the 5 volt on the Arduino. Ground of the MQ2 goes to the ground of the Arduino. Then digital output pin labeled DO on the module connects to digital pin 7 on the Arduino. The buzzer positively connects to digital pin 8 and the LED through 220 ohm resistor connects to digital pin 13. Now for the code part, the logic is really straightforward. We continuously read the digital pin. When the sensor detects smoke or gas above the threshold, the digital pin goes low, and that's when we trigger the buzzer and turns on the LED. And as you can see, the moment I bring smoke near the sensor, the buzzer starts beeping and the LED lights up immediately. When I take it away, everything resets. Exactly what we want.
My name is Saitesh Babde.
My name is Bharat Shulke.
We are here to demonstrate our IoT midterm project, which is based on human motion detection using PIR sensor. So for that we are using some components. Components are
First component is buzzer. After that, next component is Arduino Uno. Another components are some wires, and the another component is
PIR sensor, which is used for the detection of human motion, and it will give alert to our code, and which will also on the buzzer and switch on the camera and take an image. We will see the connections.
Let's see the connections of the PIR sensor. First pin of the PIR sensor is connected to the 5 volt VCC. Another pin is connected to port number 2. Next pin is connected to the ground. So connections of the buzzers are one of the pin is connected to the 8 number and one pin is connected to the ground, and this USB is connected to our laptop.
See the working of our project. Here we have PIR sensor connected to Arduino. And we have buzzer also connected to Arduino. Whenever we'll get high signal here, it will send the signal to Arduino code and it will take the image of that particular person who is standing there. Here is our Arduino code. First of all, we will compile it. Now we will upload the code to our Arduino. As you can see, uploading is done. Now our sensor is working. Now we will also run our Python script, which is responsible for our image. It will take the image basically after the signal is sent as high. As you can see, whenever the motion was detected by the PIR sensor, we got the buzzer on, and at the same time here we got our photo saved. Here we can see the photos whenever the motion was detected.
Hello everyone, this is our IoT based smart irrigation system project. This system automatically controls water supply based on soil moisture level to avoid the water usage, which is basically used for the farming. The components used in these projects are Arduino Uno, soil moisture sensor, relay module, water pump, breadboard, jumper wire and the battery. The soil moisture sensor is inserted into the soil. It detects whether the soil is dry or wet and sends data to the Arduino Uno. The Arduino checks the moisture level. If the soil is dry, it activates the relay and turns on the water pump, as you can see here now. And if after watering, if the soil is wet, it turns off the pump automatically, as you can see. This system helps in saving water and reduces manual effort in agriculture. It can be used in farms, gardens and smart agriculture systems. Thank you.
Hello everyone, I am Riddhi Bharuka
and myself Gauri Rajguru.
Today we are going to present our fundamental of IoT project, which is a color sensor that we are going to use the TCS3200 color sensor.
So let us see what is the TCS3200 sensor. So TCS3200 sensor work on the principle of the light intensity measurement. It has the array of the photodiodes.
Object is placed in front of this sensor, then the photodiodes select that reflected intensity, and then the sensor checks this intensity and convert it into a square wave frequency. Then the microcontroller checks this frequency and convert it into a color, that is whichever color is present in front of this, and it is displayed on an LED.
So let us understand what are the applications of the TCS3200 color detector sensor. So it is used in the real world applications like the color sorting robotics, then the industrial automations, then food quality checking, and the electronics projects also.
Let us see how the code is working. So here we define the pins S0, S1, S2, S3 and out for 8, 9, 11, 12 and 10. Also we are using the LED which is defined for the pin number 13. And here is the S0 and S1 is nothing but the frequency scaling. S2, S3 is nothing but the select the red, green, blue filters. Out is the output frequency for the sensor, and LED we define the function is nothing but the red color. So there is the red, blue and green colors which it pulse in. So this we change the S2 and S3 to select the filter like low, 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 high and high, high. This measures the pulse using the pulse in and store the value in red, green and blue variables. And these are nothing but the condition to detect the color.
We will see the components which we are going to use in our project. This is TCS3200 color detector sensor, LCD, LED, Arduino Uno, jumper wires. Now we have placed one object in front of our sensor, as there is a white color in front of a sensor and it's displaying the color in our LCD. So now as we will change the color, it will display the color in it. We can see that RGB value is getting fluctuated.
Now we have come to the conclusion of our project. So we conclude that this project demonstrates how we can detect the color by using the light intensity and the Arduino.
These TCS3200 sensors convert the light into a frequency, and thus this frequency helps us to demonstrate which color is detected. Thank you.
Hello everyone, myself Poonam Shere. Today me and my project partner Snehal Raktate are going to explain our mini project, a fire alarm system. This system detects smoke or fire and alert people with a buzzer and LED warning. In this project we have used three main components: an MQ2 smoke sensor, an Arduino Uno board and a buzzer with an LED. The MQ2 sensor continuously checks the air quality. If it detects smoke, its sensor value increases. When it crosses the safety limit, the Arduino immediately turns on the buzzer and the LED. The buzzer gives a loud alarm sound and the LED glows to indicate danger. Connections are completed. Now upload your code to the Arduino Uno ID. So now our code is successfully verified and uploaded. So see the output. If smoke range crosses the threshold value, then buzzer and LED will be on, otherwise they will remain off.